Hi, today we'll be talking about how you can scale your servers using a distributed system fundamental concept called as pub sub, also known as publisher subscribe model. We'll be understanding why is this required, when to use it, and the pros and cons of using a publisher subscribe model. We'll also be later implementing a publisher subscribe model in a WebSocket server that I had built for a application called UpUp. So why do I need a publisher subscribe model for my WebSocket server? Well, the answer to this question is that your WebSocket server can probably handle not more than 10,000 to 20,000 users at a single time. Now, this number is for a Node.js server running on a single thread. But even then, WebSocket servers are not meant to handle a lot of requests, like millions of requests or millions of users, simultaneous connections at a single time. The reason behind this is that a WebSocket server, by definition, is supposed to have a persistent connection with the client. So in this case, for example, let's say you have like a million users over here, of course, on different machines, and you have an HTTP server over here that you have built. Now, out of these million users, probably you're getting 10,000 or 30,000 requests per second, which you're handling very easily because they're very small requests and they are not persisted. So it can handle 10,000, it can handle like way more than 30,000 requests easily. And the actual number will depend on the kind of architecture that you have deployed your server on and depending on number of threads that you're running. But then yeah, like easily more than 30,000, 40,000, 50,000 requests in a single second can be handled by your server if it's doing like really simplistic tasks or not too complicated tasks. But the problem arises when you have a WebSocket server that is trying to persist the connection with more than 30,000, 20,000 people at a single time. It is because all the connections that it will have with each and every user will always be persisted, which means they will always exist no matter what. Even if they're not sending any data, they will still have that connection. So how can you probably scale this? Well, one way is to vertically scale your WebSocket server. That is, you increase its capacity, increase the CPU power, and just make this a behemoth of a machine, right? But again, this is like limited. Like you can't infinitely scale your WebSocket server. There is a limit CPU power you can have in a single machine, right? So this is not very scalable. So what is the other approach to this? Well, let's have a look. Now, another approach to this is to horizontally scale your WebSocket servers. So you'll be bringing new instances of your WebSocket server. The instance you feel like you're going over a certain threshold. Now that number depends on the limitations of your WebSocket server. So for example, you decide to bring a new WebSocket instance after every 10,000 users that are connected to your servers. And you've brought the system up again. But in this case, how will you ensure that these two WebSocket servers communicate? So that if a user of same room joins different WebSocket servers, you can ensure that they can communicate with each other. One solution that you can think of for this problem is that you can make sure using a load balancer or some intermediary server such that all the requests of a single room are handled by a single WebSocket server. But then you'll run into the same problem again. What if a single room has too many users for you to handle? And similarly, this other WebSocket server will be just lying idle, and this single WebSocket server, which has a lot of users, will be overloaded and probably also might crash because of the popularity of the room. So in this case, you really now need a way for your 2 or n number of WebSocket servers to communicate with each other. Well, that is the case where a pub sub really becomes useful. What PubSub does is that it allows your WebSocket servers to communicate with each other. For example, let's consider that these two WebSocket servers are connected to my PubSub that I have hosted somewhere, right? And I'm receiving requests from user A who's inside room 1. Alright, A1. And similarly, I have another user B1 who's also inside room 1. But then he's connected to WebSocket server 2 because WebSocket server 2 is probably near him or something. Now what we will be doing is that whenever we receive a data event from the user onto our WebSocket server, we'll be publishing that data onto our PubSub. And now what our PubSub will do is that it will send out the same data that we have to all the subscribers. For example, we can have n number of other WebSocket servers and all of them will receive the single message, single data. And now they can process it and identify if they have users that are in room 1. Now, for example, this WebSocket server 2 does have a user that is inside room 1. So it will process the data and then send over that data to the user B1 who's inside room 1. And this way, it doesn't matter where your user is connected to, which WebSocket server he's connected to, he or she can receive any message from any WebSocket server. And this way you can just scale your WebSocket servers infinitely, in technical terms, infinitely, to handle like millions, billions of requests at a single time. Now in this case, the publisher and the subscriber are the same WebSocket server, which are handling and processing the same kind of requests. But there could be cases where you have different publishers and different subscribers, where you have publishers publishing to the PubSub and subscribers consuming from that PubSub all at once. But since we're talking about WebSocket servers today, and this is the kind of example that we're trying to solve, this will be our major focus for the day. Now let's see how we can implement this on a WebSocket server that I've written inside Node.js. This is the WebSocket server that we'll be scaling to the moon using PubSub. This WebSocket server is of an application that I had built called UpUp, which is a chat application wherein multiple users can join a single room and then communicate with each other. And the benefit that I got because of using a PubSub was that I wasn't limited to a single WebSocket server. I could scale infinitely if I wanted to. Of course, I didn't have any users, so I didn't have to actually scale. But then just for learning purposes, I decided to implement a PubSub system inside this rather than just relying on my single WebSocket server. Let's see how it's looking like. Localhost 3002. That's where my application is running currently. Now after signing in, this is how my dashboard is looking. I'll just join any room just to show you how my application is running. For example, if I send any message to this chat room, what it will do is that it will send a message to the WebSocket server, which in turn will send it to the PubSub, and the PubSub will send it to all the subscribers of the WebSocket, which currently is just the single WebSocket server running on my machine. And yeah, that's about it. Now that you have a high level view of my applications working, we'll be seeing at how I implemented Redis to act as a PubSub for my application and how I was able to publish to it and subscribe my WebSocket server to it. We'll start by installing IO Redis into our server, which is a Redis client. Let's start pnpm. Once the package is installed, we'll start by creating a class for Redis. Let's name it Redis client. Now this Redis client will be a class because I want to associate a lot of functions to it, and I also want to make sure that there's only a single instance of Redis running on my machine. Alright, before we start implementing the functions of Redis PubSub Manager, it's important to set up Redis on our machine because of course, if we don't have Redis, how will its PubSub work? Alright, so for running Redis on our system, we can either install Redis completely or we can use its Docker image. Now, I personally prefer to run the Docker image because I don't have to install any external dependency. I can just run this single command and Docker will start Redis inside my system. Let's name it UpUp Redis. Now, this Redis client will have a few attributes such as a private instance, a private static instance, because I don't want this instance to be repeated ever, but rather being shared between all the instances of this Redis client. This will be a singleton instance, which means that there will be a single instance of the name instance, which will be shared amongst all the new a Redis client instances that we're going to create. Now there will be two more attributes that we'll be needing. That are the private publisher and the private subscriber. Now they will be of the type Redis, which will come from the IO Redis package. Now the reason that we'll be needing two Redis clients over here, that is the publisher and the subscriber, is because our WebSocket server will be acting as the publisher and the subscriber at the same time, of course, using different Redis clients. Now another attribute that we'll be needing over here is for the subscriptions. Now there'll be two subscriptions again that we'll be needing. Now subscriptions will be a map between the user ID and all the rooms that the user is subscribed to. And similarly, we'll be having a reverse subscription map. This reverse subscription map will be a map between the room and all the users inside the room. The reason that we'll be needing the subscriptions and reverse subscription, so that it will be easy for us to manage all the subscriptions of a single user using the normal subscriptions, that is the subscriptions map. And similarly, it will be easy for us to manage all the users that are inside a single room using the reverse subscriptions. Now we'll be going ahead and making our constructor of this class, but note that the constructor will be a private constructor. It is because we don't want our constructor to be used outside this client, this Redis client class. We want it to be used inside this class. We don't want to give the user access to create new instances of Redis client, because there'll be only one instance that we'll be creating for it. Now the thing that we'll be instantiating inside this will be the publisher and subscriber as two different Redis instances, and the subscription and the reverse subscriptions. After we have set up the constructor function to initialize all our attributes, we'll be going ahead and seeing how we can use the subscriber to listen on every message that it receives and then forward all the messages to the appropriate users. So what we'll be doing is that we'll be listening on the subscriber on every message that it receives. Message and channel. So what is message? Well, message is pretty straightforward. It's just the message that we'll be receiving. And channel. Now what is channel? So WebSocket servers will be connected to the pub sub. But how does the pub sub work internally? So what will be happening is that instead of being connected to the pub sub directly, each and every WebSocket server will have a few topics that they subscribe to. Now these topics are what are also known as channels. Now it's not that the WebSocket servers will be receiving messages from all the topics that are there, because that will be just too much information overload for a WebSocket server. So what we want is that the single WebSocket server should subscribe to only the rooms of the users that are present inside a WebSocket server. That is, in this case, this WebSocket server 1 will be subscribed to a topic that is related to the room 1. Similarly, WebSocket server 2, since it has only the users of room 1, it will also subscribe to the topic of room 1. And now we can use that channel, which is basically the room ID, to now forward the message to each and every user. So first what we'll be doing is we'll be getting all the subscribers. Next up, we'll be iterating over all the subscribers and using their WebSocket connections to send them messages. Next, we'll be creating a static method to get the instance. That is, we'll be returning the instance to the user so that he or she can use it. So first off, we are creating the Redis client if it doesn't exist. And if it does exist, then we'll be just returning the instance to the user directly. Now there are essentially three more methods that we need to configure before calling Redis client complete. The one is subscribe, one is unsubscribe, and the other is the send message method. So first up, we'll be looking at the subscribe method, which will be subscribing to the specific channel and adding the subscription and the reverse subscription respectively. So this is the subscribe method, which will be accepting three arguments: the user ID, the room ID, and the WebSocket connection. Now, what we'll be doing is that whenever we receive a user ID, a room ID, and the WebSocket connection, we'll be using the user ID to get all the subscriptions and then be adding the room inside it as well. Similarly, we'll be using the room ID to get all the reverse subscriptions, and then we'll be adding the user inside it as well. Now note that whenever we are adding the user, we're also adding his WebSocket connection along with it. Now finally, we'll be checking if the user is the only member, that is the first member to be present in the room. If they are, then what we'll be doing is that we'll be subscribing to that channel. Remember that the channel ID and the room ID are the same. That's how we have configured it. So we'll be just subscribing to the room, and then we'll be able to receive messages whenever something is published to that channel, that is published to that room ID. After we've made sure that the user can subscribe to the room, that is the consumer of the Redis client class can subscribe to a specific room, we'll be going ahead and making a method for sending the message. So the send message will be accepting 3 arguments again, that is the room, the message, and the sender. So the room is what will be used to publish on a specific channel. First, let's create the payload that will be sending. So the payload will be something like this. We have a type message, and the payload itself will have an ID, a sender, and a message. Let's import the UUID as well. So next up, what we'll be doing is that we'll be using the publisher to publish it on the room. That is, use it to publish it on the channel. Because the channel and the room ID, because the room ID is what we'll be using as a channel key. We'll be passing in the room as the first argument over here, and we'll be stringify the payload, because anything in WebSocket, whenever we are sending over any data, it will always be in the format of a string. So these two methods are what are required to first subscribe and then send message to a specific room. So once we have the subscribe and the send message set up, we'll be working directly on the WebSocket server now. So what we want is that whenever the user joins the room, we want that the WebSocket server subscribes to that room if it has already not subscribed. So for that, we'll be using a subscribe method. We'll be using the Redis client, and we'll first be getting the instance. Now since there'll be a shared instance, that is where this get instance method that we had created will be useful to us. And then we'll be using the subscribe method. Then what we'll be doing is that we'll be using the send message method on every message type that we receive over here in our WebSocket server. So we'll be first getting the instance again, and then using the send message method and passing the right arguments. Now, with just these 2 additions, we'll now be able to successfully send messages. So the instant we connect to the WebSocket server, what we'll be doing is that we'll be sending in a payload of join. This is the join that we had seen to subscribe to the room. This is the data type that we are sharing, the join, and then we are subscribing to the room. Let's see what we see when we are sending a message. Send. And we receive it over here. So first we have sent the message, which will be sent using a WebSocket server and then be published using a WebSocket server. And then since our WebSocket server is also acting as a subscriber, and it's subscribed to the room of ID, whatever this room ID is, we'll be receiving a message of the appropriate type, and that can be displayed over here using WebSockets on the front end. Now, how WebSockets work on the front end and how I'm using it on front end to pass through these messages is a topic of a different video. But basically, yeah, this is how it works, and I'm able to receive messages on my front end using a pub subsystem. Now, finally, the last thing that we need to take care of is the unsubscribe method. That is what will happen if all the users leave the room, or what will happen if there's no subscription for a user. Well, in that case, what we'll be doing is that we'll be accepting the user ID and the room ID, and we'll be removing the subscriptions respectively. First, we're getting all the user subscriptions, and if there is user subscription, then we're just taking the ID of the room and then deleting it from the user. And now, furthermore, if there are no subscriptions in the user itself, then we'll be deleting the user from the map that we have saved. Now, how will this be used? So whenever the WebSocket server is closing is when we'll be running the unsubscribe method. And this is what it'll be looking like. Great. So we have covered how a pub subsystem works in Node.js. and how it can be used to scale a WebSocket server horizontally. Now, how to actually horizontally scale a WebSocket server using AWS auto scaling groups or something similar is a topic for another video, because that is a very deep topic and a very intensive topic, and it definitely deserves its own separate video. Now let's discuss the benefits that we got from the pub subsystem and how a pub subsystem can sometimes be difficult. That is the cons of a pub subsystem. So the pros of the pub subsystem, of course, were that we were able to very easily scale our WebSocket server. We didn't have to write too much logic. We just had a simple subscriber and a publisher. The publisher published messages, and all the subscribers that were subscribed to the specific channels received those messages. So you can see how this pub subsystem is like much better than a single WebSocket server running. So one of the biggest disadvantages of a pub subsystem is that there's no guarantee of the message delivery, because that's the nature of the pub sub, right? It's completely decoupled from each other. So you cannot ensure that a message has been received or not. This is also known as the two generals problem, and I'll be linking down an amazing video by Tom Scott, who's gone much deeper into this. Now in one of the upcoming videos, we'll also be talking about message queues, which is another fundamental concept of handling asynchronous messages and events on a server, on the server side. Yeah, and that's all for this video. See you in the next one.